To start, what we're going to do is we are going to talk about the distance and midpoint, the distance of these 2 points, the distance between those 2 pink points on the board. There's a formula for this, which I will be giving you, but I hate the distance formula. The distance formula makes things way more complicated than they need to be. Right? All we're looking for is how far is it from negative 4, 2 to 4, 5. And it's a much simpler concept than the distance formula makes it out to be. The easiest way, in my opinion, to think about this is by thinking about it in terms of the Pythagorean theorem. That distance is just a hypotenuse. And all of you took geometry, and so you've had the Pythagorean theorem before. So what we need to do is we need to find those legs. The way to find those legs, besides looking at the picture, is look at the x-coordinates and say, how far is it from negative 4 to positive 4? Gritch? 8, right. So that side's going to be 8. But we don't even need a picture to do this. And how far is it from 2 to 5? 3. With or without a picture, those are the 2 legs of the right triangle. And what you're doing then is you're going to set up a Pythagorean theorem to find the hypotenuse. To me, that makes more sense to the high school mind than the distance formula. You don't even need a calculator. And on most distance formula questions, a calculator is probably necessary with all the negatives and stuff going on. And like I said, you don't even need a picture. If I cover up the picture, I can get my 8 and 3 without it being there. And there's my legs for my Pythagorean theorem. Okay? So I just did a distance formula question, a distance question, without the formula. Sometimes you can use the formula. You can use the formula all the time if you want to. I'm just telling you that I don't use it unless it's a question that's kind of backwards and calls for it. Okay? Here is that formula. Looks like that. And if you look at the formula, you'll see that the formula is just the Pythagorean theorem. The A and the B are inside a root. So they've taken the concept of the Pythagorean theorem. They're not saying it's a Pythagorean theorem. They're just turning it into this formula. And if all you've known of the distance formula is plug in numbers, subtract square, and take the square root, you're not understanding what it is. It's just the Pythagorean theorem. Is all it is. Most of them you can do in your head. The midpoint formula I actually kind of like, because you're doing basically what you would do in your head. The formula is actually true. To find the middle point between 2 coordinates, you're kind of averaging the x's and averaging the y's. Add them up and divide by 2. Makes sense. Solid. Okay? You will be getting a formula sheet probably tomorrow that has formulas for the whole chapter. You don't have to memorize any formulas. There are none painted on the wall because you get them all on a formula sheet. Okay? All right, so let's take a look at this one. Finding the distance from 0, 3 to 4, 0. Using my method that I just showed you, we look at it and we say, all right, how far is it from 0 to 4? 4. So we write 4 squared. That's one of the legs of our triangle. How far is it from, with the y's, 3 to 0? 3. And that's the other leg. Okay, now if you're catching on, if you paid attention last year, you might start to see that this is a special triangle. That it's going to end up being a 3, 4, 5. Okay? When you start to make connections, you start to see those things. If you didn't, you can go ahead and solve for it, and you would get 5. If you use the formula for this one, perfectly okay. Here's what it looks like. Compare it to what I just did. The red is the formula. You run into all kinds of potential problems, like in the middle there it says negative 4 squared. A lot of you have screwed that up this year because you don't put the negative in parentheses when you square it, and your calculator tells you the wrong answer. Ways that the formula can get you. Okay. I prefer the magenta side of the screen. And then I drew a picture to show you. It's just the Pythagorean theorem. All right, you try one. All by yourself. Using the way I think about these, what I would do is say, how far is it from negative 1 to negative 5? 4. And then how far is it from negative 6 to negative 4? 2. And then I put that together. And one thing that you have to do with these is you must simplify your root if you can. No decimals. Answer 2 root 5. Here's what that one looks like with the formula. Look at all those negatives in the top section, the top line. Look at all those places to screw up. It can be done. There's nothing wrong with it. I just like my way better. We'll skip that one. All right, let's try this one, which is more difficult. First, let me explain what you're going to do. I'll give you a hint. All right, there's negative 7, 7. And somewhere on the line, negative 4 something, I want to know the point that is 5 away from negative 7, 7. I'm drawing the picture for you, basically. This point is 3 away, so that's not it. I want to know the point that is 5 away. All right, go ahead. One way to think about this, kids, without doing any work, is if you're good on the 3, 4, 5 thing, you might be able to see, now that I drew that 3 in, 3, 4, 5. So we're looking for the point that is 5 away from the line. So there's one. Which would be at the point 4 up from that one, negative 7, 11. And if you noticed, you could also go this way. And you have a 3, 4, 5 going that way. And that would be at the point negative 7, 3. So that's one way to get the answers without really doing any math. Just seeing that a 3, 4, 5 exists one way or the other. Don't have to do it that way, but that's one way to do it. Here's another way to do it. Take the distance formula that I showed you and put in everything that you know, which would be that the distance is 5 and the 2 points that they gave you, plug them in. And now what you want to do is solve for C. So you've got to start moving everything over to the 5 side except for C. So negative 4 minus negative 7 is 3, squared is 9. Square both sides. Subtract 9. Now when you take the square root of 16, square root of both sides of the equation, you get plus or minus 4. And add 7. And those two numbers are 7 plus 4 and 7 minus 4. Those are 11 and 3, which are what I got over here. 11 and 3. Okay? So you can either do it algebraically or by looking at it. Another way to do it, if you want another way, from x to x is 3, and you can see that they're 5 apart, so it's kind of a 3, 4, 5 deal. So you're looking at it and you say, all right, from C to 7 has to be 4. So what's C going to be? You could do it that way. It's just another way to think about it. Lots of different ways to think about it. All right, let's move to